Okay. So chapter 4, we're still going to be using the supply and demand model, but for a different purpose. So in chapter 3, we're just learning how the supply and demand model worked to illustrate the decision making. And we also talked about how to illustrate the market equilibrium and then how the market equilibrium price and quantity can change. The purpose in chapter 4 is to illustrate how buying and selling makes us better off. Okay, so when we buy and sell, we're better off. The sellers are better off because they make money. We, the buyers, are better off because we get to have stuff. Okay, so everybody's better off when we can buy and sell from each other. So there are gains from trade, right? That was principle number 5 from chapter 1. Okay, so these gains from trade are the fact that we are better off. And we are better off because we get a net benefit when we buy or sell something. So a net benefit is the difference between the benefit and the cost. And there is a net benefit as long as the benefit is bigger than the cost. And this net benefit is also called surplus. So the surplus is derived by the buyers as well as the sellers. Okay, now for the sellers, this is basically their profit. So when you sell something, the benefit of selling something is that you get paid money, but then you had a cost to make the good, and so then your profit, of course, is the difference, and that would be your net benefit or your surplus. So for producers, the net benefit is the difference between their revenue, so that's what they get paid, and their costs. So producers become better off because they make a profit. Now for consumers, we become better off because we get to have stuff. And we derive various types of satisfaction from the stuff that we buy. Now, we also have a surplus or a net benefit, which is the difference between the benefit we get from a good and what we have to pay for the good. But for consumers, it's a little bit more abstract. Now, for the producer, it's not, right? They can measure the price they're paid minus, they can measure the cost, they can calculate exactly what their profit is, very measurable. But for the consumer, it's a bit more abstract. When you go shopping for something, what's the benefit? Well, it's whatever you think the satisfaction will be from whatever it is that you're buying. Can you measure satisfaction? No, right? You can't say, oh, I'm going to get this many dollars of satisfaction from this pair of shoes, right? We don't think that way. We just think, okay, these shoes are cool or they're comfortable, whatever. And you try and think then, is the satisfaction that I'm going to get worth it to pay the price for the shoes? Okay, so we're comparing a satisfaction or a feeling compared to the price that we're going to have to pay. But we do, so we don't really measure the satisfaction, but we do kind of, because we have to decide, is the amount of satisfaction worth the price? Right? So is the amount of benefit I'm going to get, is it more than that price? And if it is, then I will buy the shoes, and if it's not, then I won't buy the shoes. All right, so the way that we think about it when we're at the store then is, am I willing to pay the price? Am I willing to pay that price? Okay, so for consumers, we think about how much are we willing to pay. Now, for a pair of shoes, we will think then about how much are we willing to pay for the shoes. So if they're really cool shoes or very good quality or whatever, you might be willing to pay a lot for them. You might be willing to pay at least $100 or more for the pair of shoes. But then there's the actual price of the shoes. So if they're really great shoes and you are willing to pay as much as $100 for them, but they only cost $20, how are you going to feel? Super excited, right? Because that's going to mean you're getting a great deal. And that is your consumer surplus then. That feeling of being super happy because they were great shoes, but you only had to pay $20 for them. That means you're getting a lot of surplus from that buying. But if the same pair of shoes that you were maybe willing to pay at most $100 for, if they actually cost you $90, now you'll buy them because you're willing to pay $100 and they only cost $90, so you're willing to pay the price, so you buy them, but you're just not quite as excited about it as if the same pair of shoes was only $20. Okay, and that you're not as excited because you're just not getting as much surplus in that case. All right, so for the consumer then, what we think about is what are we willing to pay, and then what's the price that we actually have to pay. Okay, so consumer surplus or net benefit. So our net benefit is the difference between the benefit measured by willingness to pay and the price actually paid. So again, this is kind of an abstract concept though, because when you are in the store, you're thinking about your willingness to pay, but usually you're not coming up with an exact number. You're not coming up with the fact that you're willing to pay $101.92, right? You're not going to do that calculation in your head, but you're in an abstract way, you are kind of doing that because you're going to decide whether or not to buy the shoes. And if the shoes do cost $110, you're going to say, no, I don't want to buy that pair of shoes. That's too much. But if they're $90, I will. Okay, so that means my willingness to pay is more than 90, but less than 110. Anyway, so we do think about what we are willing to pay. And it is the consumer's willingness to pay then. It's not what we pay, it's just what are we willing to pay. So it's like the maximum price that you would pay if you had to and you'd buy the good. Okay, so a consumer's willingness to pay is the maximum price they would pay. So the maximum price they would pay, which is also called the demand price. Okay, but again, it's not usually the price that you do pay. Usually, the price that you actually pay will be less than that, and then you'll get some surplus. Okay. We have a willingness to pay for anything that we get satisfaction from, and we will all be different though because we all have different incomes which would affect our ability to pay, and we all have different preferences which would affect how much satisfaction we're going to get from goods. And we also, when we're buying something, we think in terms of marginal costs and benefits or per unit. So if right now, you're probably, some of you, pretty hungry. So let's say somebody is out in the hallway selling donuts. You have a marginal willingness to pay per donut. Okay, so let's say you buy the first donut, you eat the donut. What would happen to your willingness to pay for the second one compared to the first one? It would be a little bit lower, right? Yeah. So the first one, you're going to be willing to pay the most for it because at that point you're hungry. and you will get lots of satisfaction from eating the donut. But once you've eaten the donut, the first one, you're not as hungry. So the second one will taste good, but you're already not as hungry. So it's not going to provide quite as much satisfaction. But you might still buy it, and then you eat it. And then what happens to your willingness to pay for the third one compared to these ones? Even lower, right? And so as you eat the donuts, you get satisfied, right? You start to fill up. Your willingness to pay per donut will go down and down and down until at some point you say, okay, well, that's enough donuts. I don't want to buy any more donuts. Okay, so our marginal willingness to pay, or willingness to pay for one more unit, it will decrease as we consume more and more of the good. Or it will decrease as the quantity of goods purchased increases. Okay, so as we consume more and more of a good, or as we acquire more and more of a good, our willingness to pay for even more will go down because we become satisfied. Now, for some goods, it takes a lot before we are completely satisfied. And for other goods, it might only take one or two. Okay, so for example, your phones. Most people only have one phone. Because what would you do with the second phone? Now, some people might have like a personal phone and a work phone. Okay, so then there's the benefit of having the second phone. But for most of us, your one phone does everything that you need done, so why would you pay for a second phone? You're not going to. So most of us, we have a willingness to pay of quite a bit for the first phone, but then the second phone, maybe if it were like free, you'd take it, but otherwise you wouldn't take it, right? Because your satisfaction from a second phone would be very small. Whereas some things, say like socks or pens, we have lots of those ones. We get satisfied at some point, but not until after we have a larger quantity of things like that, because it's more useful to have more of those things. All right. Okay, so our willingness to pay for the good is also called the demand price there. It's given by the demand curve. So when you have a demand curve, it slopes down, as we were discussing in Chapter 3, because people will only buy more of the good when the price goes down. Why is that? Because they become satisfied. So for the first few units, they have a high price that they're willing to pay, but as they get more and more of the good, the price that they're willing to pay goes down and down and down because they become satisfied, and at some point they just don't want any more of the good. So the per unit willingness to pay is then the price that the demand curve tells us. So this tells us that for the 10th unit, the person is willing to pay $5. For the first unit, they were willing to pay quite a bit. For the second, a little bit less, and so on. And so each unit will be a little bit less of a price that they're willing to pay. Okay, your consumer surplus then, let's see here. Okay. Oh, okay, that first. Okay, so marginal willingness to pay. So marginal means per unit, so willingness to pay for one more unit. And then we can also say that this is the demand price, or the price at which you would buy that unit. So this is not the same as the price that you actually pay, though, right? So looking at the demand curve here, the $5 is just what the consumer is willing to pay for the 10th unit. So if the price were $5, they would buy 10 units. But they would quite happily buy the 10th unit for less than $5. And so the diagram doesn't actually tell us what the actual price is. It just tells us what they're willing to pay for the 10th unit. So for the 10th unit, they're willing to pay $5. If they have to pay $5, then they'll have no net benefit. They'll buy it, but they won't have any net benefit. Whereas if at the 10th unit, if they only have to pay, say, $1, then they're going to have a net benefit or a surplus. So you get a surplus or a net benefit as long as the price you're willing to pay is more than what you actually have to pay. Okay, so that's your surplus. The difference between what a consumer is willing to pay and what he or she actually pays. Okay, so per unit, your consumer surplus would be your marginal willingness to pay minus the price, or total for when you buy more than one unit, then it would be the sum. Any questions so far? Yeah.
Why is it a straight line?
The demand curve?
Yeah, the marginal willingness to pay.
Okay. Why does it go down, or why is it straight as opposed to curving? Okay, so realistically, it might not be a straight line. Yeah. But we don't want to use any quadratic functions in this class. We just want linear functions. So therefore, when we do calculations and draw graphs, we just draw straight lines, yeah. But if you go on in economics, then you'll learn about more realistic looking functions maybe, yeah. It could be that the willingness to pay goes down more sharply or more slowly, yeah. Okay, so let's see. Example on the next page is about puppies. So, looking at the table, what we have for a person is number of puppies and then their marginal willingness to pay. So this is per puppy. And your willingness to pay per puppy will change as the number of puppies increases. So, for everybody, you're willing to pay, everybody who wants a puppy anyway, you'd be willing to pay the most for the first one. But then once you already have one puppy, that's providing you with some puppy satisfaction. So for the second puppy, you're not willing to pay as much. And after you have two puppies, then you're definitely more full of puppy satisfaction. So for the third puppy, you're willing to pay less. And for the fourth puppy, less. And then for the fifth puppy, that's not going to provide any additional satisfaction, so you're not willing to pay any for the fifth puppy. Now, you have to decide how many puppies to get. They cost $100 each. All right, so for each puppy, you would consider, am I willing to pay enough money to cover the cost? All right, so first one, are you willing to pay enough? Yes, $400, you're willing to pay enough to cover the price. Second puppy, will you buy it? Yes. Third puppy? Yes. Fourth puppy? Just barely, but yes. Yeah, just barely, but yes, you are willing to pay the price. Fifth puppy? No, you're not going to buy the fifth puppy. Okay, so this person, who obviously likes puppies, is going to purchase 4 of them. He or she is going to purchase all the puppies for which the willingness to pay covers the price or the cost. All right, so this person will buy 4 puppies, or all the puppies for which the marginal willingness to pay is greater than or equal to the price. And now, how much consumer surplus is derived? Right. So this is a typical situation where you are deciding how much to buy of something. Each unit will cost you the same. So for this person, each puppy cost $100, but the benefit that the person is getting, the benefit which is derived by their willingness to pay, is different for each puppy. It's the most for the first one, and then it goes down. So for this person, their consumer surplus is the difference between what they were willing to pay and the $100 cost that they actually paid for each puppy. So how much surplus did they get for the first puppy? 300. 400 minus 100. So they got $300 of surplus from the first puppy. How much surplus for the second puppy? 200. So 300 minus 100. From the third puppy, they get 100. And from the fourth puppy, no surplus on that one. Yeah. Okay. So total surplus, total $600. Now you can calculate the surplus two ways. This way, what we did is we took the willingness to pay minus the cost for each unit separately and then added it together. But you can do it another way where you calculate the total willingness to pay for all 4 puppies minus the cost of all 4 puppies. So you'll get the same answer. It's just a different way to calculate it. Total willingness to pay for all 4 puppies would be 100 plus 200 plus 300 plus 400. That would be your total willingness to pay for the 4 puppies. And what the person actually pays for the 4 puppies is the price times the quantity. So she buys 4 puppies at $100 each. Okay, so the person's total willingness to pay for the 4 puppies is 1,000, cost, price times quantity, 400, and so then the surplus is $600. All right. So now we'll show it in the diagram. Okay. Use some different colors here. So total willingness to pay. Now what we've got is marginal willingness to pay here, which is graphed as a bar chart, kind of rather than a straight line. So you can see that it's like a demand curve though, like it goes down because the marginal willingness to pay for each unit becomes smaller and smaller. Here's the price here, $100, and so the person is choosing 4. So as long as the willingness to pay per unit is greater than or equal to the cost, they will buy the unit. So that's all the way up to the last one here. Willingness to pay is then this line here. So she's willing to pay 400 and 300, 200, 100. So this whole area would be the person's total willingness to pay. My colors over here. So I've got this bracket over here, meaning the whole area is total willingness to pay. And then the cost that they actually pay is the price times the quantity. So that will always be this rectangular area. So the cost is the price times the quantity. Cost. And so then the surplus is the difference, which will be this area up here, consumer surplus. we're doing here is we're just illustrating how people are better off when we buy stuff. We all know that we're better off when we buy stuff. We're better off because we get satisfaction from the good. What's going on though, first of all, so things that you've learned so far in all the chapters, starting in chapter 1, is that we make decisions at the margin. So for each puppy, we think, okay, what's our willingness to pay? What's the price? Okay, as long as our willingness to pay covers the price, we'll buy the good. Okay, so with that marginal decision making, that's how we reach the quantity. Okay, so this person chooses the quantity of 4. That quantity makes them better off. How much better off? Well, we measure the satisfaction that the person is getting from the puppies, minus we measure the cost, and now we have the net benefit or the surplus for the consumer. What will happen if the price changes? So right now the price is 100. If the price goes up, what's going to happen to the number of puppies that they buy? They'll go buy less, that's right. And how will they feel about it? Not as good. They'll feel not as good about it because they don't buy as many puppies, but also because they're paying more per puppy. So what happens to their surplus per puppy? It goes down. So they've got less surplus per puppy, fewer puppies. So when things are more expensive, how do we feel about it? We don't like it. And now you've got the proper vocabulary to talk about it. You don't like it when the price of something you're buying goes up because you buy less of it and now you've got less surplus from it. Yeah. Okay, so on the next page, the price is $2.50. Okay, so the price here is $250. How many puppies will the person buy? Now, you can figure that out from the graph. So they'll buy the puppy as long as what they're willing to pay covers the cost. So they'll buy the first one, they'll buy the second one, but then after that, the cost becomes more than the benefit to them. So they won't buy any more than that. So they'll buy 2. Okay, so they're going to buy 2. Okay, so they buy 2 puppies. Their willingness to pay is $400 and $300, and they get 2 of them. So this will be their willingness to pay. And then the cost is the price times the quantity of 2. So this part will be their cost. And so then their surplus is obviously a lot smaller. Okay, so how much surplus do they get from the first puppy? They pay, they're willing to pay $400 and they pay $250, so $150. And for the second puppy, they're willing to pay $300, they pay $250. So total $200. All right. Last one, let's do the last one too. If the puppies are free, how many puppies would they get? Oh, I forgot to put the 2 up here. QD will be 2. Now, if the puppies are free, what quantity would they get? 5. They'll get all 5 of them. Okay. Now, in that case, there's no cost. So the benefit is measured as the willingness to pay, and there's no cost to subtract. So that means that the consumer surplus is the whole thing. There's no price. Okay, so all of this will be consumer surplus. And so then the consumer surplus is the willingness to pay, and there's no price. The price is zero, so minus zero. So $400 for the first puppy, 300, 0, and so that's a total of 1,000. Good. So that person would then be super happy because they are getting the maximum puppy satisfaction possible. Okay, good. So these graphs here are, you could call them like a step curve or a bar chart, but for the rest of the chapter, instead of having the step curve or bar chart, we're going to just draw a line. So you imagine just drawing a straight line through the bars, and then that is the demand curve. So this essentially is also a demand curve, but it's just drawn differently. And the calculations are just more tedious then, because you have to add up the marginal willingness to pay and surplus for each unit. But if we just draw a line, then we can just calculate an area of a triangle, for example, for the consumer surplus. So it's a lot easier, and we can use linear functions. So that's what we will do for the other examples. Okay. So here we have a demand function and a price. So first thing to do is calculate what quantity will the consumer buy. All right, so we put 4 in for the price. Okay, and then we'll fill in the graph. All right, so I'll start with the demand curve. Now the demand curve starts at p equals 10, so that's that number. And then the horizontal intercept will be 20, because there's a slope of minus 0.5. And then this point here is the price of $4, and they will buy 12. All right, now for the consumer, the area under the demand curve tells us the total willingness to pay. The demand curve, like the point, each point along the curve represents the marginal willingness to pay. So for the 12th unit, the person is willing to pay $4. But the total willingness to pay for all 12 units would be the area under the curve. Just like when we had the puppy example, we would calculate the total willingness to pay as this area plus this area plus this area plus this area. So in other words, the area under the curve. Okay, so total willingness to pay would then be this trapezoid shape here. So trapezoid shape. And I'll just make a note over here. So when you have this kind of a shape, you have 2 parallel sides with different heights. So height 1 and height 2 and a width. And so then to calculate the area, you add the 2 heights together, multiply by the width, divide by 2. All right, that's a half. Okay, so that's supposed to say half. It looks like y2, but it's supposed to say 1/2. Okay, so let's do that for here. So total willingness to pay, height 1 is $10, height 2 is $4. And then times the width, which is 12, and then times 1/2. I'll write it like that instead. So that's $84. Now, in the diagram, I'm going to label this one, the triangle part as A and the rectangle part as B. So, and then I'll just make a note over here that this would be A plus B together. So then, the amount paid, or the total cost. So that will be, total cost is the number of units you buy times the price. And so that is the area below the price. So just like in the puppy example, when the cost or the price was $250 per puppy, and she buys 2 puppies, that would be $500. And so that would be this rectangle here, 2 times 250. That would be the cost for the consumer. So that will be price times quantity. So 4 times 12, so that would be area B. Okay, so the amount paid, or total cost, so that's area B. So then what area is the net benefit, or the surplus? What area would be the surplus? A, that's right. And there's 2 ways that you can calculate it. You can either take 84 minus 48, or you can use the formula for a triangle. So I'll write it down both ways. Okay, so it's area A, so you can take 84 minus 48. Or use the formula for a triangle. So then the height of the triangle would be 10 minus 4, and then times the width of 12 times a half. And then, of course, that's the same answer. Okay, so that's area A. Okay, so total willingness to pay, or total benefit, is the full area under the demand curve. The amount that the person actually pays is area B. And then, so then the surplus, or the net benefit, is area A. Okay, so again, what we're doing here is we're measuring how much better off people are when they can buy stuff. Now, what happens when the price goes down? How do you feel about it when the price goes down? Yeah, you're happy because the net benefit goes up. Now, your net benefit will increase when the price goes down for 2 reasons. So partly because the price per unit goes down, so you're getting a bigger surplus per unit. But then also when the price goes down, you buy more units, right? So you buy more and you're getting a bigger net benefit per unit. So yeah, so you're happier. Of course you're happier. Okay, if the price goes up, exact opposite, right? When the price of something goes up, you're not happy. You're not happy because at a higher price you don't buy as much, and your surplus per unit is now lower because the difference between the benefit and the cost becomes smaller. Okay. So on the next page, we're using the same demand function, but now the price is going to go up to $6. Okay, so same function though. So the function from the previous page, P equals 10 minus 0.5 Q. Okay, now the price is 6. So first thing is to figure out what quantity will the buyer get. Okay, and then we'll put that in the graph. So at $6, there will be 8 units purchased. So 8 units are purchased. So the benefit of the 8 units is this trapezoid now, so a smaller benefit, obviously, because they're getting less of the good. But then the cost is higher, so now the cost part is here. So they're paying more per unit. And so then the net benefit, or the surplus, will be this triangle. Okay, so net benefit, because the demand curve measures the benefit minus the cost, which is the price here. Okay, so CS new, so new consumer surplus, we'll just calculate this as an area of a triangle. Okay, so 10, equals A. Okay, so we'll call that A. All right, so they had $36 before, now they've only got $16, so they've lost $20. So the new surplus is $16 minus the calculation from the previous page was $36. So they've lost $20. Okay, so delta CS is the minus $20. And the area that is equal to this $20 is the difference between what their surplus was before, which was this bigger triangle down to here, and the new little one. So I'm going to add some letters here. So B will be this rectangular area, and C, the triangle area. So the minus 20 is the B and C. So the B and C area is equal to $20. Okay. Now, when the price changes, it changes how well off we are, how happy we are with our consumption for the two reasons. It changes the cost per unit, and it changes the number of units that we're getting. We can see this in the graph. Okay, so when the price was 4, and they bought 12, when the price was 4 and they bought 12, or 12, you can say 12 people bought the good at this price of $4. Now only 8 people are buying the good at the newer, higher price of 6. Okay, so say it's like one person, each person is buying 1 unit. So there was 12 people here, only 8 consumers there. So what's happening? Well, for all the consumers, the demand curve tells us what they're willing to pay. All right, so these 8 people here have a willingness to pay that's high enough to cover this price of 6. So they still buy the good. They also, of course, bought it when the price was 4. For these 4 people here, their willingness to pay is lower. And it was high enough that they were willing to pay the price of $4, but it's too low to pay the new price of 6. So these 4 people here don't buy the good anymore, and we say that they exit the market, which means you just don't buy the good anymore. Okay, so they're losing surplus for 2 reasons. These 4 people are losing surplus because they don't even get the good anymore. These 8 people lose surplus because they pay more. They still get the good, but now they've paid more for it, so then they're not as well off from the purchases. All right, so this is like, say you want to buy something, you think the price is $4, you go to the store, now it's $6, you're like, oh, okay, well then some people would say, okay, I'm still going to get the good. And that would be one of these 8 people. They'll say, okay, I'm still going to get the good. I'm not as happy about it though, because now I have to pay $6 instead of paying $4. But some people would go to the store and see the new price of 6 and say, no, it's not worth it anymore, so I'm just not going to get the good. And then they are not as well off because they don't get the good at all anymore. All right, so The area B then represents the consumers who will still buy the good, but they have to pay more. And then this area C represents the 4 people who just don't get the good anymore. Okay, so first here, so for area B, so this is the loss of surplus. So the loss of consumer surplus for consumers who, we would say they still buy the good. So the proper way to say that is that they remain in the market. They remain in the market, they still buy the good. It's just that now they have to pay more for it. And we can calculate area B. So it's a rectangle, so 6 minus 4, so 2 times 8. So area B would be $16. So they've lost $16 of surplus because the price went up by $2 per unit, and they're by 8 units. Okay, and then area C is the loss of consumer surplus. And then we would say that these consumers exit the market. So they're the ones who just say, oh, forget it. It's not worth it at that higher price. Okay, and then last thing, we can calculate area C. So it's an area of a triangle. Okay, so 2 times 4 divided by 2. Any questions?
I don't understand like what the change in consumer surplus is going to be.
Oh, like what area it would be?
No, like why does the change in consumer surplus be listed?
Oh, well, compared to 4. So the price was 4 to 6. So at $4, consumer surplus was this bigger triangle down to, so from 10 down to 4 and over to 12. And now it's only here from 10 to 6 and over to 8. So it used to include this when the price was 4, and now it does not include that. So delta just means the difference between what it is now and what it was before. Yeah, this here. And so this area here, the loss of consumer surplus is equal to $20 because this triangle was $36 and this is $16. So this is $20. And then all we did is we divided it up because when the price goes up, we're worse off for the 2 reasons. We're worse off because we pay more and we get less of the good. All right. Okay, exercise 1, same function. Same function, but now the price is going to go down. All right, so for sure, people are better off when the price goes down. You plan to buy the good at $4, you go to the store and it's on sale for $2. You're super happy. You're super happy because the cost per unit is going down, and also because you will buy more, or more people will buy more. Okay, so at $2, first we'll calculate what quantity that people will buy. Okay, so they'll buy 16 units. And the new consumer surplus is the difference between the benefits received for the 16 units. So there's the benefits received for the 16 units. Here is the cost they pay for the 16 units, or the price per unit. And so this is what we want to calculate then, the new consumer surplus. Okay, so 10 minus 2 times 16 times a half. By how much has consumer surplus changed? At $4, they only got this much surplus, which we had calculated as $36. So delta CS, so the new one, 64 minus the old, which was 36. Okay, so consumer surplus has increased by $28. And this increase, this delta CS, this increase, the difference between the original smaller triangle and the new one, the increase would be this part here. And again, we can talk about the two reasons why the surplus changes. The surplus changes because more people get the good. So these 4 people here, at the previous price, they did not buy it because their willingness to pay was not high enough to pay the price of 4. But now that the price is 2, their willingness to pay is high enough, so they will buy the good. So they're better off because they didn't even have the good before, now they get to buy the good. These 12 consumers are better off because they still buy the good, obviously, but this used to be their cost up to here. Now their cost is only down here. So this part becomes part of their surplus instead of being part of their cost. Okay, so let's label these B and C again. Okay, so the portion of the increase in consumer surplus for consumers who were already in the market, that would be the 12 people here. They were already buying it when the price was 4. They still buy it, of course, at the lower price. So for them, they get the extra area B. And then the next one, the portion of the increase that's for the new consumers, so that's between 12 and 16, that would be the area C. Now, last question, what would consumer surplus be if the good were free? Now, how many units would they get? At a price of 0, they would get 20. That's right. So at a price of 0, they're going to get 20 units. So now consumer surplus is going to be the whole triangle because the demand curve measures the benefit and then the cost is nothing. The cost is zero. So the surplus will be the entire triangle. Just like last week with the puppy example, the last one here was consumer surplus when the puppies were free. They got all puppies, and so what we were calculating was the area, the whole area under the curve. Right.